The electrical service installation observed is characteristic of older buildings. Visual perspective can sometimes distort perception, making the wires appear closer to the roof and building than they actually are. The actual distance between the wires and the roof surface is likely to be at least 12 inches. This separation provides sufficient clearance to mitigate potential electrical hazards. It's critical to verify such clearances during inspections to ensure code compliance and safety. The National Electrical Code, or NEC, outlines specific requirements for conductor clearances to ground and building structures. These requirements are designed to prevent accidental contact and minimize the risk of electrical faults. Furthermore, the wires are typically supported by insulators. These insulators are essential components that prevent direct contact between the energized conductors and the building structure or any grounded surfaces. Insulators are usually made of porcelain, glass, or other non-conductive materials that provide a high level of electrical resistance. The presence of insulators significantly reduces the likelihood of electrical leakage and helps maintain the integrity of the electrical system. Firstly, consider the conductor size and ampacity. The conductors must be appropriately sized to handle the anticipated load of the HVAC equipment. The ampacity, or current carrying capacity, of the conductors must be sufficient to prevent overheating and potential insulation damage. The NEC provides tables such as Table 310.15, which specify the allowable ampacities for various conductor sizes and insulation types, based on factors like ambient temperature and installation method. Secondly, grounding is a crucial aspect of electrical safety. The electrical service should have a proper grounding system to provide a low impedance path for fault currents. This ensures that overcurrent protective devices, such as circuit breakers or fuses, will quickly trip and de-energize the circuit in the event of a fault. The grounding system typically includes a grounding electrode conductor connected to a grounding electrode, such as a ground rod or a metallic water pipe. Thirdly, overcurrent protection is essential to protect the conductors and equipment from damage caused by excessive current flow. Circuit breakers or fuses are used to interrupt the circuit when the current exceeds the rated capacity of the conductors. The overcurrent protection devices must be properly sized to coordinate with the conductor ampacity and the equipment's requirements. Fourthly, examine the condition of the insulation on the wires. Over time, insulation can deteriorate due to exposure to heat, sunlight, or moisture. Cracked, brittle, or damaged insulation can create a significant electrical hazard. If the insulation is compromised, the wires should be replaced to ensure safety. Fifthly, ensure proper support and securing of the conductors. The wires should be securely supported to prevent them from sagging or coming into contact with other objects. Proper support also helps to reduce stress on the conductors and connections. Cable ties, straps, or other approved methods can be used to secure the wires in place. Sixthly, check for any signs of corrosion or damage to the electrical equipment. Corrosion can weaken connections and lead to electrical failures. Any damaged equipment should be repaired or replaced promptly. Regular inspections can help identify potential problems before they escalate into more serious issues. Seventhly, verify that all electrical connections are tight and secure. Loose connections can cause overheating and arcing, which can lead to fires. All connections should be properly tightened using the appropriate tools and techniques. Eighthly, assess the overall condition of the electrical panel or disconnect switch. The panel should be free from any signs of damage, corrosion, or water intrusion. The door should be properly secured, and all components should be in good working order. Ninthly, consider the environmental conditions in the area. Exposure to harsh weather conditions, such as extreme temperatures, humidity, or corrosive elements, can accelerate the deterioration of electrical equipment. Proper protection and maintenance are essential to ensure the long-term reliability of the electrical system. Tenthly, consult the NEC and other applicable codes and standards. The NEC provides comprehensive guidelines for the safe installation and maintenance of electrical systems. It's essential to be familiar with the relevant requirements and to follow them carefully. Additionally, local codes and standards may impose additional requirements that must be met. In addition to the NEC, other relevant standards may apply, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards provide guidance on specific aspects of electrical safety and design. Proper documentation of the electrical service is also crucial. This includes maintaining accurate records of the wiring diagrams, equipment specifications, and inspection reports. This documentation can be invaluable for troubleshooting problems and for future maintenance and upgrades. It's also essential to ensure that all electrical work is performed by qualified and licensed electricians. These professionals have the knowledge, skills, and experience to safely and effectively install and maintain electrical systems. Attempting to perform electrical work without proper training can be dangerous and may violate local regulations. Remember that the information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations and to ensure compliance with all applicable codes and standards. A thorough inspection of the electrical service should be conducted to verify its safety and compliance. This inspection should include a visual examination of all components, as well as electrical testing to verify proper grounding, insulation resistance, and voltage levels. Any deficiencies identified during the inspection should be promptly corrected to ensure the safety and reliability of the electrical system. Regular maintenance is also essential to keep the electrical service in good working order. This includes periodic inspections, cleaning, and tightening of connections. A proactive maintenance program can help prevent problems before they occur and extend the life of the electrical equipment. When performing any electrical work, always follow proper safety procedures. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and energizing the circuit before working on it. If you are not comfortable working with electricity, it's best to leave the work to a qualified electrician. The overall assessment of the electrical service requires a comprehensive approach, considering various factors such as conductor size, insulation, grounding, overcurrent protection, and environmental conditions. Compliance with the NEC and other applicable codes and standards is essential to ensure the safety and reliability of the electrical system. Regular inspections and maintenance are crucial to prevent problems and extend the life of the equipment. Always consult with qualified professionals for specific recommendations and to ensure that all work is performed safely and in accordance with applicable regulations. Proper electrical service is vital for the safe and efficient operation of the HVAC equipment and the building as a whole. A well-maintained electrical system can help prevent fires, electrical shocks, and other hazards. It can also improve the energy efficiency of the building and reduce operating costs. The age of the building is also a significant factor to consider. Electrical systems in older buildings may not meet current code requirements and may be more prone to problems due to wear and tear. Upgrading the electrical service may be necessary to ensure safety and compliance. This could involve replacing old wiring, installing new overcurrent protection devices, and upgrading the grounding system. When upgrading an electrical service, it's important to consider the future needs of the building. This could involve increasing the capacity of the service to accommodate additional electrical loads or installing new circuits to support new equipment. Planning for future needs can help avoid costly upgrades later on. Furthermore, it's vital to consider the specific requirements of the HVAC equipment. The equipment manufacturer typically provides detailed specifications for the electrical service, including the voltage, amperage, and circuit protection requirements. These specifications must be followed carefully to ensure proper operation and to prevent damage to the equipment. The type of HVAC equipment installed also affects the electrical service requirement. For example, a large chiller may require a dedicated electrical service with a high amperage capacity. Smaller units, such as rooftop package units, may be able to be served by existing electrical circuits. It is also crucial to consider any energy efficiency measures that can be implemented as part of the electrical service. This could involve using energy-efficient transformers, installing power factor correction capacitors, or implementing a demand-side management system. These measures can help reduce energy consumption and lower operating costs. When evaluating the electrical service, it is important to consider the potential for future expansion or modifications. If the building is likely to undergo renovations or additions, the electrical service should be designed to accommodate these changes. This could involve installing spare capacity in the electrical panel or providing conduit for future wiring. Proper planning for future needs can help avoid costly and disruptive upgrades later on. In addition to the technical aspects of the electrical service, it is also important to consider the aesthetic aspects. The electrical equipment should be installed in a neat and professional manner, and the wiring should be concealed where possible. This can help improve the appearance of the building and create a more positive impression. Lastly, it is vital to remember that electrical safety is paramount. All electrical work should be performed by qualified and licensed electricians, and all applicable codes and standards should be followed carefully. Regular inspections and maintenance are essential to ensure the continued safety and reliability of the electrical service. The apparent proximity of the wires may warrant a closer inspection to ensure compliance with local codes and ordinances regarding clearance from structures. While the photograph can be misleading, confirming the actual distance is a prudent step.